In this video, we're going to look at the formal definition of the mathematical concept of sequence. The definition is not going to look exactly like what you may remember from your calculus class, but this is the formal definition, and in many calculus classes, you only look at an informal definition. And we will tie this back to that informal notation by the end of the video. But to begin with, the formal definition of the word sequence in a mathematics class is this. A sequence is a function from the natural numbers to the real numbers. That's all it is. As an example, if I let p go from the natural numbers to the real numbers, be given by the formula p of k is equal to 1 over k, we have a perfectly good sequence. So we have a sequence. Now, there are several ways that we can think about this sequence, most formally because it is a function. So I want to kind of get this idea down. The formal idea is that because this is a function, P is a set of ordered pairs. And the ordered pairs all look like k comma p of k. So in our example, they would look like k comma 1 over k. And because of this, the formal notion of the graph of a sequence is simply found by plotting all the ordered pairs of the form k comma 1 over k. So in our particular example, so our example, remember, is that p goes from n to the real numbers is given by p of k is equal to 1 over k. We need to plot let's see, 1 comma 2, 2 comma 1 half, 3 comma 1 third, 4 comma 1 fourth, and so on. And if we actually go about trying to plot this, what we're going to need is we need a y-axis and we need an x-axis. And then we're going to have to, I'm going to make a unit up here very big in the y direction. And we'll have lots of little units down here. So this is not a true scale plot. So this is 1, 2, 3, 4, 5, 6, 7, and so on. The points on the points for y is equal to p of k would look like this. I'm going to put them in white. That is my first one. Let's see, that would be about where my second one is. This would be about where my third one is, and the fourth one, and the fifth one. And they're getting closer and closer and closer to the x-axis. So this would be 1 comma 1, 2 comma 1 half, 3 comma 1 third. And then this would be 4 comma 1 fourth, and 5 comma 1 fifth, and so on. Now, this kind of way of graphing a sequence is a little bit awkward, and there are easier ways of thinking about what's going on with the sequence. So I want to kind of now talk about how we actually work with sequences. So in practice, this is what we do. In practice, we focus on the actual elements in the image of the natural numbers, but we also focus in on them as an ordered list. And we typically write the sequence p going from the natural numbers to the real numbers as, and we use set braces, but this is an abuse of the set brace notation. So we're opening up a curly Q set brace, p sub k, as k goes from 1 to n, and we write this as p1, comma, p2, comma, p3, comma, p4, comma, p5, and this list never ends. And this is where pk is nothing more than p of k for k equal 1, 2, 3, and so on. Now, it's important to realize that the elements on our list are not necessarily distinct. So they are not necessarily distinct. And this means that this notation up here, this notation here that we're using, is a little bit of an abuse of set theory notation, because most of the time in set theory, sets are unorganized lists where we do not include duplicate elements, or we can get rid of them whenever we want to. So it's important to note that the image of my sequence P is a set, and we usually think about the image as unordered and typically no repeats. And we're going to write the image of P as P of the natural numbers. But we're going to reserve this particular notation for the ordered list, P1, P2, P3, P4, and so on. So this will actually mean the ordered list of the y coordinates, if you will, of the sequence. Because remember, the sequence itself is got ordered pairs. Now, we typically read, so that's also another thing that I want to introduce. We read this notation as the sequence of pKs as k goes from 1 to infinity. And the meaning, of course, is that k is going to be an integer. So it is implicit in the notation. And let me clean up that bit of not very good writing. It is implicit in the notation that k is a positive integer, that k is a natural number. There's one more convention that I want to add here too, and that is how we typically graph sequences in a real analysis class. So we also tend to graph the elements of the sequence as single points on the number line. And the easiest thing to do here is an example. And for our example, we're just going to continue to look at the sequence that we were looking at before. We're going to let the sequence of pKs, as k goes from 1 to infinity, be given by 1 over k as k goes from 1 to infinity. And if we want to graph this, we can just graph it on a number line, and I'm going to make a great big number line here. And our number line is going to have 0 here and 1 here. And what we are going to do in order to graph this particular sequence is we're going to put a dot for each term of the sequence at the correct place. on the number line, and we will label it as pk. So let's start looking at these particular terms. P1 is 1, so P1 is 1 is there. P2 is 1/2, so it's halfway between these two things. So this here is P2. P2 is 1/2. P3 is 1/3 of the way between 0 and 1. So let's see, that would look about like right here. P4 would be about here. That's 1/4. P5 would be about there. So P5 is about here. And P6 would be about here. And so on. So this would be a picture or a graph of the 6 terms of our sequence. Now, the final thing that I want to note is some vocabulary stuff. And this is a little bit tricky, but just a little bit of vocabulary. In English, sequence and series both mean the same thing. They are both essentially an ordered list of something. We can talk about a series of events or we can talk about a sequence of events, and they mean the same thing. So they're synonyms, they mean the same thing. But in math class, sequence means, let's get my sequence means ordered list, and a series is something else. It is a sum of an ordered list. Now, we're not going to look at series in this class, but you looked at series in Calculus 2, and it's important to realize that in math class, we cannot use the word sequence and series to mean the same thing. So we cannot call the things that we're studying series. They must be referred to as sequences.